do that here. All right, I work at UTSA. Worked there for 7 years. I'm a senior software engineer, and today we're going to talk about Git and how to use it. Not GitHub, not GitLab, not Bitbucket, not any of that stuff, but just Git. Have some extra time. You'll have questions about like any of those services or whatever, then we can dive into that. And you've got a whole hour, so we'll see what we get done in an hour. But I can talk a lot about this stuff. So for those of you who are wondering what is the on PowerPoint, all of my slide titles are Git commands just for the hell of it, because I figured why not? That would be fun. If you're here and you want to learn about Git, you really don't understand what this means, but it's kind of fun. And then maybe after this, you'll understand what it means. All right, cool. We'll get into it. So what are we going to talk about? We're going to start with what is Git. Then a lot of this is going to be a demo. It's not going to be PowerPoint, because PowerPoint's a boring. So then we'll actually do the basics. I'll like jump into a terminal. And since we've got these tiny little screens and people are like all the way back there, we're going to paint some screens. But there's like visuals hopefully to help you guys understand what else is going on. And if we get all the way down to the bottom, we get all the basics. Then we talk about this cool topic called rebase versus merge. It's like the hottest topic on the planet when it comes to Git. Is like which one do you use? So I'll share my opinion and why I'm talking about it. All right. So what on earth is Git? So the VCS, but better. What's a VCS? It's a version control system, version control software for any kind of whatever you want this to stand for. But basically it means that if you're, let's say, like writing a Word document, you're writing a Word document for class, and you're like, you finish your first draft, and you save that off as like draft 1, and then you keep going, and then you save the next draft as draft 2, and you keep going. So Git is kind of similar, except we're doing all of that in a line. And it understands the difference between points in time. And so if you've ever been like writing code for a class and you're like, you get like an hour down the line and you're like, man, I did. Yeah. All right, cool. And you're like, oh man, like an hour ago, I had what I needed, but now it's gone. So I just spent an hour going down like the wrong path and doing the wrong stuff, and I just didn't understand what I was doing. If you were using Git the whole time, you could just be like, cool, let's go back to when that happened. So we're going to talk about how all that works. But basically, it helps you as a solo developer, like manage your code base as time goes on. As a group of developers collaborating on a project together, it can also help you in that way. So Git was originally invented by Linus Torvalds, the guy who invented Linux, because at the time he was writing Linux, he was like, none of these other version control systems really are working out for me. I don't like them, so I'm just going to go invent a new one. He decided that this was the way. Basically, Git is a mini file system. So other version control systems store diffs, and you might think of Git as that's what it's doing. In fact, for a long time, that's what I thought it was doing. So like if you have a file and you edit that file and then you give that file to Git again, you might say, well, the easiest way to understand, and keep track of changes over time is to just look at the difference between the two files and store what changed, right? And so that's the way other version control systems work. Git's actually different. It stores kind of like the entire state of the universe over and over and over and over again. And so that way, whenever you go back to what Git called a ref, or a point in time, it kind of reverts everything. And then lastly, everything is checksum. So I don't know who's taking maybe like a networking or a security class or any kind of class that knows what that means. But basically it means that every time you do something in Git, it checksums the result to make sure that it's actually getting everything correct. So you're not going to like, say, corrupt your repository by committing something, because everything is checksum. And so if something doesn't line up, Git's just going to be like, whoa, something's like real wrong here. We're gonna stop. Like whatever's happening, just don't do that. All right, so a lot of fun trivia, I guess, about Git. That's good to understand, and just how you're interfacing with different things. Like if you've ever, I guess, raise your hand if you ever use like GitHub, GitLab, Bitbucket. All right, we've got a decent amount of people in here. So if you've ever interfaced with one of those like pieces of software out on the web, They're all just remote repositories, is what people call them, right? They're remote Git repos stored up there. How does that work? So technically in Git, everything is a repository. Your local is a copy of all of the refs that are up there in the real repo. And you may not have all the refs, but you can choose what you want to check out. So usually the remote has everything, and then you have some sub copy of that. But in terms of how it all works, my machine, this laptop right here, you guys could commit to my laptop. Yeah, I could commit to your laptop or your laptop or your laptop. It all works the same. The only difference between doing that and interfacing with one of those like big guys, GitHub, GitLab, etc., is that they provide a nice little user interface and wrapper experience on top of all of that for you. So Git is a system. You don't have to interact with one of the giants. You can set up a Git server on like a Raspberry Pi sitting in your house. It'll work just the same way. It's actually really, really easy to do. So that's what they really are. And then you also see a lot SSH versus HTTP. Should I use one or the other? Really, it doesn't matter. A lot of people start with Git over HTTP just because they don't know the difference. That's what I did forever. Every time you push, you enter your username, you enter your password. And it's because it's using HTTP's form of basic authentication. It's up to you whether you want to use one or the other. One's not necessarily better. The only advantage you get over SSH is usually we're using SSH keys to like exchange credentials. So A, you're not having to type your password every time you commit. So you'll see like today when I'm, okay, what are you doing? Don't do that. You'll see when we get to like demo stuff and I'm like pushing up to a repository, which all of you guys can go and get. I'll give you the link to that later today. I'll be using SSH because I won't have to type my credentials over and over and over again. So one or the other, one you just have to generate an SSH key and use it that way. I think it's a little bit easier. All right, great. Let's actually talk about Git with a terminal and some commands instead of boring PowerPoint. Exit. Elijah, can you still see my screen? Where'd he go? All right, he's gone. Hopefully everybody can see my screen. Oh, infinite screen. Where did my terminal go? Where did my browser go? Cool. All right, so I've got the repo out here. Anybody that wants to access it, this is the repository. So it's at my GitHub username, which is W20, and then it's the Git Basics repo. I think there's a few of them out there, but that's where we want to go. If you guys want to like follow along with whatever I'm going to do, this is the repository I'm going to use. I've already uploaded the PowerPoint if you guys want it, and then when we're done, we'll see if I can get a copy of the recording and I can shove it in here too. All right, awesome. So if you guys want, it's at W20 Git Basics. It should be available. All right. So I've actually already got the repo cloned down. Let me move these two guys around so this is easy. All right, and right now this is what it looks like. So this is what is this called? Git Kraken. I downloaded this yesterday. Usually I don't use visual tools for Git. I use just a terminal. And so that's what we're going to do. But I'm going to use this to show you when we interface with the terminal, what all of it does. Can you guys actually see this? Let me make it bigger. Is that better? Probably a little better. All right. So as I interface with the repository, you guys will be able to see kind of what's going on and how it's actually working. And so that way you won't have to like imagine in your head everything that we're doing, hopefully. And it should be a little bit easier. All right, so we're going to use Git from the perspective of I'm a single user, but I'm going to act like multiple people because most of the time when people are using Git, it's not just them. It's like them and a friend or them and a group of people or like a whole team and a company developing stuff. All right, so let's start off with some really basic stuff. If you just type Git, and that is going to show terribly, but if you just type Git into your terminal, you get a list of everything that it can do. If I make this smaller for just a minute here, hopefully we can see this better. So we got a list of everything it can do. It can do a lot of stuff. So most of the time you will use maybe a small percentage of all of these. We're going to try to go through a good majority of them. And we'll see how far we get. Let's like blow this up again. All right, let me know if you guys can't see this all the way back there and I can make it even bigger. or we can try to make it even bigger. All right. So we'll start off with probably the most basic thing. So actually, let's start off with. All right, we're going to start off with cloning stuff. So I'm going to take my repository, usually on places like GitHub or GitLab or Bitbucket, etc. There'll be this like little like code or clone or something button. When you hit that, you'll get some options. It's got an HTTPS option, an SSH option. I guess they have their own command line. I'm going to use the SSH one. And so to get any repo from some remote repository to your local machine, you're going to use a command called git clone. So git clone basically says, I want to clone what's on the remote onto my local machine. So you just type git clone, and then you can paste in whatever URL, HTTPS URL you've got from the website. And when you hit enter, you'll notice it says it's cloning into Git Basics here. It will by default name where it clones something after what the repository is called. If you want 2 copies of it for, I don't know why you would want that, but if you do, and sometimes this comes in use if I want to like edit one copy just for funsies and do all kinds of weird stuff to it, and then the other one's like the real guy. You can actually, after you specify the URL, tell it where you want it to put it. So we can say like, I don't know, dummy repo. So you'll see the first one said it's cloning into Git Basics because I didn't tell it, so it's going to name it after whatever the repo is called. The second one, I told it, hey, go to dummy repo, so it's going to say, hey, cloning into dummy repo. And so now I have 2 different projects, one called Git Basics and one called dummy repo. We'll use the one called Git Basics because we're going to be nice about it. So the first thing you can do is you can do a git status, and you can actually see what branch you're on, whether or not it's up to date. If I changed something, like let's say I deleted like the README, right, and then I did a git status, you can see that it would tell me like, hey, like you're on branch main, your branch is up to date, and you have changes that aren't staged for commit. So let's talk about that. What on earth does that mean? I have changes that aren't staged for commit. So Git has what they call a staging area, right? So every time you make a change, right, that exists on your local, but you don't have to put that in Git. Like, let's say I just make another file for the heck of it. Like, let's make, I don't know, hello.txt. Great. So there's hello.txt, right? If I do a git status, you'll now notice that I've got changes that aren't staged for commit and untracked files. So both of these are red because they aren't staged. So if I don't want to do anything with them, like let's just say I try to make a commit right now, and we can just ignore what this looks like. But it'll tell me at the bottom here, let's get that higher so people can read this, but it'll say no changes added to commit. Use git add or git commit -a to add changes, right? So in your staging area, let's just look at our staging area. In our staging area is blank. So let's say I don't want to commit this readme.md file. Like I really hate this file, so I just deleted it, but I don't actually want to delete it in the repository, right? So it's deleted on my local machine, but I don't have to push that up. So how do we stage something? So it tells us to use git add to stage stuff. So if I type git add, there's a couple of things we can do. I can type the name of the file that I want to actually add to the staging area. I can type a dot, which means everything, right? I can type a star. I think that also means everything. I can also do -A. That also means everything. You'll see a lot of people do this a lot, and they get themselves into trouble really quickly because they start adding stuff that they didn't mean to add. So maybe like you're working on a project and you're making some test data and you're like filling up test data with like a bunch of garbage. You've got this whole directory of like test nonsense. And then you're like, cool, the code works. Let me just commit it. And you just do like a git add dot or git add -a to add everything. Next thing you know, like all that garbage data is like in your repo. And once it's there forever. You can get rid of it very easily. So be a little mindful, I guess, of what you're committing. Another thing you will see all the time is they've got test scripts that they're using. And I see this, unfortunately, in corporate environment sometimes too. They've got a test script and they're like, cool, this test script has my username and password in it, right? Because I'm just testing, right? And next thing you know, they're like, cool, well, whatever I was testing, like, let's say I have like some piece of code and I'm testing that piece of code for my little script, and I just have my username and password in there because I'm not going to commit it, right? But then, it works. I'm like super excited. I'm like, oh, great, let's get that in the repo. Git add dot, git commit, git push, boom, test script with my credentials is in the repo. So they're like, oh crap, what do I do? So they're like, oh no, let me like just delete it and then I'll commit that. Well, you can go back in time to their previous commit. And even if you're like really fancy, like we'll talk about this in a minute, but even if you overwrite that previous commit, those Git objects are still in the database. So they do still exist. So the point is, be mindful of what you're committing. So if we do a git add, which I guess is already here, we can specify a file like hello.txt. When we do this, if we get nothing back, that's good. So we'll go ahead and clear this off the screen. We'll do another git status. And hey, look, now it tells me changes to be committed. There's this new file called hello.txt, and it's like changes not staged for commit, deleted readme.md, which is good because I don't want to do that. And so maybe I want to undo that. Maybe I like deleted readme.md by mistake, right? Because a lot of times, like maybe you're just messing around and you're like, oh crap, I like deleted all these files. And especially if you do it through the terminal, right? Like that doesn't go to like your trash can, it's just in the ether, like it's gone. Another reason to be using Git, by the way, because you can undo that. It's okay because Git knows that file existed. It knows what its contents were, right? It's not in the ether, right? So we can use a command called git restore, and then we can type readme.md. Oh, it won't autocomplete because it's dead. It's not there. So, and you'll notice when I did git restore readme.md, it looks fine. If I do an ls, look, it's back. It's chilling. It's right there. There's readme.md. It's back. So now, if I do a git status, you'll notice that no longer does it tell me, hey, there's this file that you deleted. You should add it to your staging area if you want to commit it, or don't do that if you don't want to commit it. Now it just tells me, hey, there's a new file. Because it understands the difference between states of what's in the repo now and what was in the repo. So now if I want to commit this change, right, the best practice, so if I just do git branch, we'll be able to see that I'm on the main branch, right? Main, master, whatever you want to call it. We're on the main branch, right? So the best practice is to use a separate branch. When I went through, I think like most of the way through college, I never used separate branches. We just all kind of committed to the main branch. And then this thing would happen occasionally where like, let's say like Tasha over here like changes a file and then I change the same file in like roughly the same place and then gets like, I don't know what just happened. Like she added this file that has changes and you're trying to add this file that has changes. There's all these like crazy conflicts and it's like, I don't know what to do. And then it puts all this weird stuff in your source code that's like all these arrows and pound signs and whatever else. And we would just be like, I don't know, just like manually copy and paste to make like the file look better. And we would just try to like figure it out that way. So there are ways to get rid of this. We'll talk about those in a second, but for best practice, we're going to do what's called check out a new branch before we make this change. So how do we do that and what is a branch? So a branch is sort of like this area of development where you're doing your changes and you live in this like little pool, or you can think of it like branches on a tree, right? Like if squirrel A has like the branch one, right? And you're like, cool, I want a place to hang out. I'm going to go make my own branch over there, right? But nobody messes with the trunk of the tree. That's like your master branch, right? Nobody's going to mess with that. That grows over time based on the contributions you make from your independent branches. So to check out a new branch, we're going to do git checkout -b, and there are other ways to do this. So if you know Git, there's like probably like 50 ways to make a branch. This is the way that I find is the most useful because you can both make the branch and check it out in the same command, which is really nice. So we're going to do git checkout -b, and we can just name our branch. I don't know. What are we going to name this? Let's name it RowdyHacks. Cool. So we've got a branch called RowdyHacks. You'll notice it told me, hey, I switched to a new branch called RowdyHacks. And if I run that git branch command again to see what's going on, you'll notice that main is now in white text and RowdyHacks is green and it has a little asterisk just in case like colors aren't your thing. Then we've got this little asterisk here that tells us this is what's currently selected, right? And if I had like 100 branches, you could see all of them. There's actually a git branch-a, which that'll show you some different stuff, and we can talk about what those bottom ones are in a second. We'll get to that. That's more complex. But this will show you everything that's out there technically. All right, so I'm on my new branch called RowdyHacks, right? So let's actually do ourselves a favor. So we've got, if we look at our status, we've got this new file called hello.txt. It's been added to our staging area, right? Which is where we need to add things if we want to get them into the repository. So let's go ahead and actually commit that change. So committing a change just basically means I'm ready to make a commit to a point in time where I'm going to say, hey, stuff changed. This is a point in time that's important, and I did something. And then you're going to tell it what you did. So a lot of you guys are YouTube, so hopefully y'all are free of terminal. But if I just do git commit, we get what looks like this VI looking screen. And that's what it is. It's VI. So if we hit I, we can go into insert mode, and we can start typing stuff. I'll show you the other way to do this in a second. But we can start typing stuff, and we can say, you know, like, oh, I don't know, we changed, I don't know, added the hello.txt file, right? Okay, and then we can get out of here, and great. So now it'll say, hey, look, you made this commit. This is its identifier, 801xcc9, and we added the hello.txt file, and then you can see one file change, 0 insertions, 0 deletions. We'll get to what that means in a second. And then it says create mode, you know, that for hello.txt file. Great, look, it worked. So on bigger commits, you'll get bigger messages. On smaller commits, you get small little messages. The point is that you can commit often. So now let's talk about this other command, right? So let's talk about git log. So if I want to see what's going on, I can type git log, and we'll look at a visual representation here in a second. Because this is insane to understand, but when you learn how to read this, this will be better. This will save your life a lot. But this will tell you, hey, remember where it said that ID for the commit was like this 7 little letter thing? It's technically a lie. It's a actual like much longer shot, and this is it. So this is the actual ID of the commit, and it was made by me. You can see there's my email address. This is the time that it was made, and this is what the message says, right? And so you can say, you can see here, like me preparing for the presentation today on Friday, March 24th at last night. Look, added presentation and updated the README. Wow, look at that. And so way over here at the left side, you can see way over there, on the screen, origin main, and then this says origin head, and then this says main, and then this guy up here says head little arrow, it says RowdyHacks. So what does this mean? This is a list in order of what the commit graph looks like. It's trying to show it to you in the terminal. This, yep. This probably makes a lot more sense. Can you guys see that back there? That's as big as it's going to get. Hopefully you guys can see this, but this probably makes a lot more sense. So this is here. This is the initial commit. This is what happened when I made the repo. GitHub gave me a little readme.md. And then I made this commit. That's what we just looked at, that docs, add presentations, and update the readme, right? And you'll notice that it's telling you, hey, this is on the main branch. And you've got this other thing over here, RowdyHacks with a check mark, and that added hello.txt file, right? Okay, fantastic. So let's say that, and let's make this commit graph a little more complicated, because now we got to talk about some other stuff. So I can continue making all these commits all day long. So I can come in here and say, edit the hello.txt file. And there's, I didn't put anything in here. So I can say like, hello, me. I am me. Great. We've got stuff in there. So we've got stuff in our hello.txt file. If I do a git status, right, it should show us, hey, we modified this file. but it's red. What does that mean? Yeah, it's not staged. I heard somebody say it. It's not staged, right? So in order to do that, we've got to add it, right? Okay, so now if we do a get status, it'll tell us, hey, it's green. It's been modified. Let me like do that again. Hey, it's green. It's been modified, right? And if you want to restore it, you can do this. So if you have staged something, there's a slightly different way to restore it. You just add this dash dash stage to the restore command because it's already in the staging area. So now let's commit it. So we'll do a git commit. This time I won't hit enter here. So for anybody that's like afraid of VI, like I was in college because nobody taught me how the heck to use that thing, then you can add this -m flag for message, right? And then you can just type in what you want your commit message to be. So you get a single line, and technically this is the title line of the commit, but we won't worry about that. So we can say like added content to the hello.txt file. Great. So you'll notice now that before, you remember when it said like one file added, 0 insertions, 0 deletions? Now it says one file changed, 1 insertion. So what that means is I made an insert and effectively I changed a line in the file. So typically, by the way, when you get out there in the real world and you start like collaborating with people, you want to make like small, succinct changes. And as you go forward, you want these numbers to stay really small, because otherwise, when they have to review the work that you've done, it's going to take forever. But so keep these small as you go through, and it's better. You'll often hear people say commit often, right? It gives you the ability to go back in time a lot easier and say, oops, I messed up here. I should have never added that there, or I want to revert this here, whatever you want to do. All right, great. So we've got that. We'll learn about our last, what I'll call simple git command, and then we'll go on to like more fun advanced things. So the last thing that I can teach you is git push, right? So git push is going to take what's on your local machine and push it to wherever the origin is. And if you don't remember where your origin is, you can always look at what your remote points to. So if you do a git remote -v, it will tell you, hey, you have these origin things. One's for fetching and one's for pushing. We can talk about that later. But for most projects, they're going to match. If they don't match, you're onto some advanced stuff and you know what you're doing. So, but this is git@github.com, wswinney, gitbasics.git. Perfect. That's exactly where I want it to go. So if I do a git push, it's actually going to tell me, oh no, something bad has happened. It said the current branch RowdyHacks has no upstream branch. What does that mean? That means if I go look in my browser, not that one, this one. Move this thing over here. Get out of here. All right. If I go look at my browser and I click on branches, look, there's only, where does it go? There's only one branch. It's main. That's it. There's no RowdyHacks branch here yet. That only exists on my computer. So what it's trying to tell you is I need to understand how you want to link this to which remote. Because you can have many remotes. There can be all kinds of different remotes. You can have one for, I don't know, when the sky is blue, and one for when the sky is green, and one for when it's raining, and one for when it's sunny. You can have all kinds of ones. So it's like, which one do you want? Now, we only have one, so I made a guess here. It's like you probably want to do git push -- upstream origin RowdyHacks. And that links back, that origin links back to, oh, it's right at the top. These origins here, when you did that git remote -v. And so you can have many remotes. We only have the origin one. For most projects, that's all you'll have. So instead of doing what it's going to do, I'm going to show you a cool way to do this. You're going to do a git push -u, which I don't know why it doesn't tell you this, but that's the short form of -- set -upstream, because we don't got time to type it. So we're going to say origin RowdyHacks. Okay, and you're not going to automate. And now it'll do all this fancy stuff. So it'll tell me, hey, like, I'm taking these objects and counting them, and like making compression for them, I'm writing them, blah, blah, blah. It'll tell you all of this stuff. And you guys don't have to understand what all that means. But at the very bottom here, which let's move that up a little bit, it'll tell you, hey, there's this new branch, RowdyHacks, that points to the remote branch of RowdyHacks. So it says branch RowdyHacks set up to track remote branch RowdyHacks from origin, right, which is our remote repository. So now if I go back to GitHub and I refresh this page, hey, look, RowdyHacks is there in our branches list. Dun, 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 we've done it. And so this is what our current commit graph looks like. It just looks like a straight line. And so that's not very fun. Let's make this a little bit more challenging for ourselves. So now let's say that, okay, so let's talk about checking out other branches as well. So as you know, you've been making changes to your RowdyHacks branch. So if we look at our branch here, we're on the RowdyHacks branch. This is fantastic. This is where we've made all of our changes. I want to go back now to the main branch. Like I pushed up my changes. I'm done with those changes. Now I want to make some different changes on a different branch. So I'm going to go ahead and check out the main branch. So I just do a git checkout main, similar to before how we did a git checkout -b. That -b that says, hey, this branch probably doesn't exist. I'm going to need you to create it for me. If I did a git checkout -b main, it would tell me that branch already exists. You just want to do git checkout. So git checkout, just without any options, how you move between things. So you should remember that we created that hello.txt on the RowdyHacks branch, right? So if I do an ls, you'll notice hello.txt isn't here. That's because it's in a different place. It's in the RowdyHacks branch. So let's say, I don't know, I'm going to become like Joe now, and Joe is going to be doing some Joe development. So we'll go ahead and check out another branch. We'll call this like Joe stuff, right? So Joe's doing stuff, and Joe is going to make a file called joe.txt. And I don't know, let's edit this, and we'll say like, hi, I'm Joe. Great. All right, awesome. So Joe has a joe.txt file on the branch Joe stuff. So I can do a git status, and it will tell me that it's not my staging area, right? And over time, you can start to see how this becomes very repetitive, and it'll start to stick in your head as like, what files are where, what state am I in? Like over time, this will start to stick in your head. The next part is where we're going to need the visualization. So Joe's been doing some work on Joe.txt, and he's really proud of it. And so he's going to go ahead and add Joe.txt, and then he's going to go ahead and commit his changes. And he's going to say, here are my changes. Great. That's actually going to give me something else too. All right, perfect. So great, here are my changes. He added a file. He made one insertion to that file. Fantastic, right? Joe's on top of it. And Joe's like, cool, I'm done with this now. We know that it's going to ask us, where do we want to put this? So we want to put it at origin Joe's stuff. Fantastic. Oh, there it goes. Wow. Yeah, so let's look at our commit graph now. That looks a little different. What does that mean? So this means that we've got our initial commit, our documentation commit where I added the PowerPoint slide and updated the readme file. Right now we've got two branches. We've got RowdyHacks, which is this one over here, this little whoop, and that guy hello.txt and content to the hello.txt. And then we've got Joe stuff over here. And Joe just here with changes, right? And so this is great, but what happens when Joe over here, we'll actually use GitHub just to show you this and how this works. So if we refresh our branches here, we've got a couple of branches, and we can come over here to pull requests. So this is typically what you'll do in like a real development environment. You'll make what's called a merge request or a pull request or any kind of different thing depending on what tool you're using. But on GitHub, they're called pull requests. And you can see that I'm acting as two developers, so it's like, which one do you want? But for the sake of this, we'll just hit new pull request. And so it's going to say, hey, what do you want to do? And I want to say, oh, yeah, I want Joe stuff. to go into master. I'm going to do it backwards. So oh God, do this the other way. I want Joe stuff to go to master. And Joe just says, hi, Joe. And we got Joe.text. So you can see what his actual changes are. So he says, here are my changes, and these are his changes right here. And so he's kind of giving you a thing. So I'm just going to hit create pull request. And here it is, right? Where did it go? Oh, it wants me to leave comments. Joe's cool. Okay, great. So we've got this pull request. And let's say we've reviewed Joe's changes and we like Joe's changes. And so Joe's changes are going to get accepted, right? So what happens when we hit merge pull request? So there's this command called git merge, which we can do locally, but it doesn't really serve a lot of point to show you that because you're hardly ever going to do that. We can talk about why. But if we hit merge pull request, and we're going to say, oh, yes, we want to confirm that this is the best thing ever, and it's been merged, and now we're going to delete Joe's branch, right? So now, if we go to the main repository, look, I've got Joe.text. And in Joe.text, it says, hi, I'm Joe. So on my local machine now, you'll notice that this graph is pretty much no longer accurate. This branch doesn't exist anymore. And main should be all the way up here, but it says, here are my changes, because Joe's pushed his stuff into the main branch. So how do we do this? So a lot of people, we know that changes have been updated on main, right? So I'm going to check out the main branch, right? And then there's this other command that you can use called git pull, right? And git pull will pull down any changes that have happened since you've last been working. And let's say you and somebody else, your buddy, are working on the same branch, right? And we'll talk about what this means in a second. There's another command, a flag you can add to this command to help you resolve conflicts later down the road. So a lot of people just do git pull and hit enter. And what this does is if there's a conflict, it will automatically create a merge commit with the conflict resolution, and it will start what a lot of people call dirtying your history. And that it decides when to make commits and where to make them, and like messing up your tree. So you can add this lovely flag called --rebase onto here. And rebasing is something that we're about to talk about right now. So we're going to do this, and then I'll show you what this does. So it'll say, great, I'm updating. I'm here, I need to be here. You know, I'm fast forwarding. Look, these are the changes that got made. Joe.text, and then you'll notice that there's this one little plus symbol. This means there was one addition. So occasionally you'll like pull down the repo, you'll have like a million of these, and like a plus sign like all the way across the screen. It's because people have made like a bunch of changes since you've last pulled. So this is good. This one little plus sign. It says one file change, one insertion. Great. This one's pretty easy, right? So fantastic. So our commit graph now looks like this. Oh, thank you, lights. So our commit graph now looks a little different. And you'll notice that this RowdyHacks is like, can somebody just kill the lights? Let's just like murder the lights. Is there like a switch somewhere? All right, we'll just deal with it. Lights are going wild. Okay. All right, we'll just live with it. It's fine. The lights are going crazy. All right. So we've added this hello.text file, and you notice that this is kind of like disjoint. And there's a reason for that. It's because this purple branch, RowdyHacks, now has a different view of the world than what the world actually looks like. It's looking at it through a lens. And let's talk about what that looks like for a second. So if I do git branch, I'm on main, right? And if I do git log to look at my log file, you'll see that I've got some commits here. So I've got a commit that's a merge commit, right? And it says merge pull request number 1 from W/Joe Joe stuff. Here are my changes. And then you've got Joe's commit here. It says here are my changes. That's the commit that Joe did on his branch, right? And then you've got added presentation update docs, and then you've got the initial commit, and that's the end of the file, right? The log, right? And so those are my 4 commits in order. If we look at RowdyHacks, if we do a checkout on RowdyHacks, so now I'm on the RowdyHacks branch, and you can see that if I do git branch. Now if I do a git log, we've got added content to the hello.txt file, right? Added the hello.txt file. Then we've got docs, and then we've got initial commit. Well, this isn't right. We're like missing all of Joe's stuff, right? So how do we get all of Joe's things into our things? So that's what we're going to talk about rebasing. And this is that rebase versus merge kind of topic. So there's two kind of strategies on how this works. One's called rebase and one's called merge. Rebasing effectively does what Git likes to call in their docs, replaying your changes on top of what already should exist. So what does that mean? Let's say I have commits like, let's just use, here, we're going to use VI. Let's, fantastic. Look at this beautiful text file. So let's say I've got commits like A, B, and C, and D, right? This is what the main branch looks like. We're just going to pretend here, right? And then we'll say like Joe's branch looks like this. We'll use RowdyHacks as an example. RowdyHacks looks like this. So it's got A, then B, but instead of C and D, it's got E, then F, right? So it's got two of these different commits. So what you want RowdyHacks to look like, so this is what we want. We want to be A, B, C, D, E, F, right? And that would be ideal. So there's two different ways to get it to look like this. One is merging, one is rebasing. Rebasing does exactly what you would think to do if you, as a human, if I gave you like, I don't know, like the little letter blocks that kids play with, if I gave you like letter blocks and I told you to like rearrange them so it makes sense, you would do this. You would take C and D, right, and move them over to RowdyHacks. So let's say you could like magically copy the blocks. You'd like magically copy them over, and then you would put them underneath E and F, right? Because that just makes sense, right? That's how you would do stuff. That's what we call a rebase. It takes what exists, gets the new changes that you don't have yet, and then takes your stuff and goes, let's just stack that on top of those, right? Because that's what you want, right? That's what's happening. You want to take the latest stuff, stack your stuff on top of that stuff. Merging does this like interlacing like kind of job. And sometimes it works great, and other times it goes horribly wrong. It really depends on what files were changed, how they were changed, in what way, blah, blah, blah. So rebasing is a lot easier. It will save you tons of time. I used to teach a class, an entry-level class at UTSA for like all the new hires that would come in on this. And I would tell them this every single time. And like about 4 weeks, they'd come back to me and they'd go, yeah, this rebasing thing, it really does save you a lot of time. I'm like, merging is easy, but rebasing saves you a crap load of time and effort. So to rebase, let's get out of here. To rebase, there's this awesome command. I bet you definitely can't guess it. It's called git rebase. So git rebase, you can either just do a rebase. We're going to specify a -i. -i means interactive. And the only reason I'm going to put a -i here, usually you wouldn't do this, is to show you guys kind of what's going on. Because we're going to get a little bit of a peek inside. So let me actually first check, because am I on the right branch? So you, in order to rebase, you want to be at your target, right? And then when you rebase, you're going to say, give me the changes from X branch, usually it's master/main, and rebase them on top of my stuff, or rebase my stuff on top of that stuff. So we're going to do a git rebase -i main. Oh. All right, and we have a lovely view here that totally makes a ton of sense. But basically what it's asking us to do is there's all these different things, all these different options we can do when we're rebasing. And it's saying, hey, these two commits are what I found that are on top of the stack that we need to pull off and then put the stuff underneath and then slap these guys back on top. So that's right. It did it. I've never actually seen it wrong. But that's correct. That's what we're going to rebase, right? Now we can choose if we want to like edit these in any way. We can actually do that during the rebase. And sometimes you want to do that, and other times you don't want to do that. We're going to choose not to do that. So this is just another VI prompt. We can get out of here the same way you would in any VI prompt. We're going to say right quit. This looks good to me. It's going to go successfully rebased and updated refs, heads, and RowdyHacks the branch. Okay, what the heck did it do? Let's go look at our visualization, which should fix yourself. Okay, the visualization is broken. We'll just use get log. This is my terminals are better anyways. All right, so before we R2 commit this, right, so we had added content hello.txt and then added the hello.txt file. And then below this were the commits that we had earlier. Siri, be quiet. Below this were the commits that we had earlier that said like for main branch, like updating the PowerPoint and adding the readme.txt and the initial commit. Now, look at that. We've got Joe's commit underneath our stuff. And we've got Joe's here, my changes. And then we've got the docs. And then we've got the initial commit. And so why is this important that we resolve all of this? When we go to make a merge request, and we can actually show you this because I haven't pushed up these changes yet. When I go to make a merge request on, let's use GitHub as an example here, pull requests. All right, we're gonna here a pull request this RowdyHacks branch. Blah, blah. Create. So you'll notice, okay, it's too smart. It's too smart, but basically what it should tell you, there's no conflicts, but what it should say is that this branch is behind by 2 commits, because it is. It doesn't have the latest history. And so it should say it's behind. It's being really smart because it knows that these 2 branches didn't edit the same stuff. So it's like, I can just fix that. They don't need to care. But a lot of times it's not true. A lot of times you'll edit the same things and it'll go, whoa, I don't understand what's happening. This is behind this other thing. Like, this doesn't make a lot of sense. Please help, right? And so in that case, that's when you can go do a rebase locally. And it's really easy. It's 1 command, and it makes your life super easy and clear and free of issues. So now let's try and push this up. So I've done a rebase. Technically, even though nothing is in my status area, when I do a get status, it will say your branch and origin RowdyHacks have diverged and have 4 and 2 different commits each respectively. Use get pull to merge. We don't need to do this because we've already rebased. We want to push up our branch to origin and make that the new state, right? So we have what we consider to be the proper state. So let's go ahead and push. It should say, rejected, failed to push some reps. And it'll say, updates were rejected because the tip of your current branch is behind. The reason it's saying that is because it doesn't understand what just happened. It's like, how did you like insert commits in the middle and now you're like trying to tell me that there's like these new, it's like, what is happening? Like what just occurred? All this state is wrong. Like it's all not in the right order. So you can tell it, you're dumb. You're just a command line interface. And this is my favorite command, get push -f. -f stands for force. It basically says, I know what I'm doing, leave me alone. So when I do this, hey, look, it works great. So get push -f says, I know what I'm doing. What does this do? Get push -f has the unique ability to do what we call rewrite history. Basically, it takes your current stuff that you have locally and says, okay, I don't care what the remote has. I'm not going to try and like decipher and like figure out how these objects relate to each other. I'm just going to like dump it into the remote and not give a crap. And that's exactly what it does. So if you had stuff on the remote, in fact, probably a good example of this, well, it's going to be hard without 2 people, but, or it'll just be really confusing to you guys. But basically, if you had changes, let's say like somebody else pushed changes up to the branch and we're both working on the same branch, if I do a get push -f, I could potentially erase their work. So just make sure that you understand that git push-f has the unique ability to do what we call rewrite history. And that is in the truest sense of the form. It will just erase what's currently there and put whatever you have in its place. So it can be useful. It can also be disastrous. I have seen people attempt to do like rebases and not check what their commit log looks like by doing a git log, and then they just push, and then it tells them they're rejected. So just fine, push -f, and then they come crying to me and they go, "Sweaty, our repo's broken. It's all empty. I don't know what happened." And I'm like, "Well, did you push -f?" And they're like, "Yeah." And I'm like, "Oh boy." So there are ways to fix it. We're not going into that now. But yeah, contact your local Git expert if you do that. So that's hopefully a introduction into how to use Git, some ways to work around stuff, some ways to use different branches. And hopefully now in all of your projects, you can all work with your friends in Git successfully and not have all those weird merge problems and other stuff when you edit similar files. Yeah. All right. What questions do you have? Is there anything I didn't cover that you're like, I want to know about this? And there's no such thing as a stupid question. Somebody told me earlier they had a dumb question. It wasn't dumb. It was actually really, really intelligent. So you never know. How do you put this in your command prompt? How do you install Git? Yeah, that's a great thing. If you've got a Mac or a Windows computer, Git is just installable by going to Git. Boop. So if you go to actually, yeah, that's what it is. gitscm.com. If you come out here, there's all kinds of stuff. You can see that this has download for Mac. If you have it on a Windows computer, have download for Windows. That'll add it to your, it'll install it to your system. It'll probably add it to your path, and you can reference it in your terminal. If you're on Windows, Git is actually a tool written for Windows, so you'll get an option, or Git is a tool, sorry, written for Unix-based systems. So you'll get an option to install via Git Bash, or I think there are now some like native bindings that you can use in PowerShell, or if you happen to know what the Windows subsystem for Linux is, definitely start using that if you've got a Windows computer, because Linux and Unix-based systems are the best. What else? Yeah. I don't know. Is the workshop going to be posted? It was streamed, so I think the answer to that is yes. So I hope the answer is yes. If I can get a copy of the recording, if you guys have this repo, if you guys pop out here to W20 Git Basics, this has the PowerPoint in it. If you ever want to reference that, if I can get a copy of the video, I'll also toss it in here and commit that up as well. What else? Nothing. Mostly just help. It's all new and scary. All right, I'll take that. All right. Have a great rest of the hackathon. And, good luck, guys. I'm leaving the studio now. I don't know if I was supposed to do that. I did. What's up?
So, I understand you're saying that it's like the secure shell and the thing.
Yeah.
So I was trying to initially like, right?
Okay.
And I do this, what you call it, about permissions denied, and say something like
Okay. So in your home folder .ssh directory, if you do like an ls /.ssh /, and then .ssh because it's a hidden directory. Put a space between the ls and the squiggly. So you don't have any keys yet. So the first thing, Google, how do I generate a SSH key? It'll tell you, you can even do how do I do it for Mac. It'll give you the command. That'll put some files in here, and then on GitHub, if you pop over to
Yeah, and then it had the thing with the SSH, so I didn't know if I had to like generate it through there first or.
Yeah, so you want to generate it on your machine, and then you'll notice that I've got one here. So this is like my personal Mac key. That's the one on this machine. So if I plug back over to, I can show you.
And so after creating like the secure shell key, it's
Yeah.
So then after creating that by doing whatever via Google, I can transfer it to GitHub.
Yep. So this is just a file, and you'll want this one. Make sure you use this id_rsa.pub, and you can actually just tap this file to. Don't do this one because that's your private key. But basically, you just copy and paste like all of this text.
Oh, so it saves your secure shell. Okay.
Yeah, you just copy and paste. You hit new SSH key. You give it whatever title you want, and then you copy and paste all that text into there,
Okay.
and then you're good to go. And then you should be able to do that.
Be able to do the clone without
Yep.
having to put it into the
Yep.
Okay.
That's it. What's up?
So this when you were talking about like merge, so this is just git merge.
Yeah, git merge is the merge command, and basically you specify when you do a git merge, you